Hello everyone. In this lecture of Z transform, we are going to study second method of finding inverse Z transform, which is known as partial fraction method. In the first lecture, we have studied first method, which is power series method. So let us see what is this partial fraction method is, how to obtain inverse Z transform using this method. Partial fraction method. Suppose given Z transform is f of Z whose inverse Z transform is to be find. Then the steps to be followed. In the first step, whatever the f of Z is given, we are going to express it as f of Z upon Z, and the remaining terms we are going to express them as f of Z divided by g of Z. So whatever this f of Z upon g of Z, this term is there, it should be a proper fraction. Suppose if it is not, if it is an improper fraction, then we have to express it into a proper fraction by performing actual division. Okay, when we say the fraction is proper fraction, when degree of numerator is strictly less than degree of denominator, else it is called as an improper fraction. So this is our first step. In the second step, whatever f of z upon z we have obtained in the first step, we are going to obtain its partial fractions and not that of f of z. So this is very important thing. For example, suppose given f of z is equal to z upon z minus a into z minus b, then we will express it as, so we will divide on both the sides by z, that will give us f of z upon z is equal to 1 upon z minus a into z minus b. Then get partial fraction of this right hand side term, which are of the type a divided by z minus a plus b divided by z minus b. Once we get this, then in the third step, again we are going to multiply resulting expression f of z upon z by z on both the sides. That will give us f of z as az divided by z minus a plus bz divided by z minus b, means of this type, not exactly like this. Based on the previous example, I have written this term here. So az divided by z minus a plus bz divided by z minus b. Okay, after this, in the fourth step, we are going to operate inverse Z transform operator on both the sides. That will give us Z inverse of f of z is equal to Z inverse of az divided by z minus a plus bz divided by z minus b, means expression of this type. What we are supposed to do? We have to operate Z inverse operator on both the sides. Once we get this, then use the linearity property of Z inverse operator, using which we will be getting a into Z inverse of z upon z minus a plus b into z inverse of z upon z minus b. Once we get this, then in the last step, we are going to use standard results of inverse Z transform or the formulae of inverse Z transform, and using which we will obtain f of n, that is the inverse Z transform. In the last lecture only, I have given you a table of inverse Z transforms of the function f of z, and after this slide also I am giving you table with additional few formulas. So please go through that table. So I hope you have got this procedure. So the procedure is containing 5 steps. So we are going to solve the example. Before that, you go through the formula of standard functions, inverse Z transform of some standard functions. So see that table. See, these are some inverse Z transform of some standard functions which we require to use directly in this partial fraction method. So please you go through that, go through all these formulas. These are very simple. We have just inverted the Z transform formulae, and we have obtained these as inverse Z transforms. Now let us go to solve the examples. Consider the first example. Find inverse Z transform of f of z, which is z divided by z minus 2 into z minus 3, and the region of convergence is mod z strictly greater than 3. Solution. So given f of z is z divided by z minus 2 into z minus 3. So express this in the form f of z upon z, for which we will divide on both the sides by z. That will give us f of z upon z equal to 1 upon z minus 2 into z minus 3. Now obtain the partial fractions of the right hand side, which are 1 upon z minus 3 minus 1 upon z minus 2. Once we obtain the partial fractions, then again multiply this expression on both the sides by z. That will give us f of z is equal to z upon z minus 3 minus z upon z minus 2. Now operate the inverse Z transform operator on both the sides. Therefore, Z inverse of f of z is equal to Z inverse of z upon z minus 3 minus z upon z minus 2. Now further, we are going to use linearity property, using which we will be getting the expression z inverse of z upon z minus 3 minus z inverse of z upon z minus 2. Here we have used linearity property. Now, to get the inverse Z transform, we are going to refer the table of standard formulae. For that, we require region of convergence. Here, we have been given region of convergence as mod Z strictly greater than 3, and which clearly implies that mod Z is also strictly greater than 2. Because of which, we can write down this term as again and for z upon z minus 3, mod z is strictly greater than 3, and for z upon z minus 2, mod z is strictly greater than 2. So use the appropriate formula from the table, and therefore inverse Z transform of Z upon Z minus 3 for mod Z strictly greater than 3 is 3 raised to n, and for Z upon Z minus 2 for mod Z strictly greater than 2 it is 2 raised to n, which gives us inverse Z transform of the given function as 3 raised to n minus 2 raised to n. So inverse Z transform is 3 raised to n minus 2 raised to n for n greater equal 0. So in this way we can use partial fraction method to find inverse Z transform of the given function. Let us see one more example. Find inverse Z transform of z square plus z divided by z square minus 3z plus 2 if 1 is less than mod z less than 2, which is the region of convergence, that is annulus. Now in the solution we will consider f of z, which is z square plus z divided by z square minus 3z plus 2. Now get f of z upon z, means divide both the sides of the above expression by z. That will give us f of z upon z equal to z plus 1 divided by z minus 1 into z minus 2. We have factorized the denominator. Now get partial fractions of the right hand side, which are 3 divided by z minus 2 minus 2 upon z minus 1. Once we get the partial fractions of the RHS of f of z upon z, then multiply that expression on both the sides by z. Therefore, f of z is equal to 3z divided by z minus 2 minus 2z upon z minus 1. Now, operate the inverse Z transform operator on both the sides. So, Z inverse of f of z is equal to Z inverse of 3z upon z minus 2 minus 2z upon z minus 1. Use the linearity property that will give us z inverse of f of z is equal to 3 into z inverse of z upon z minus 2 minus 2 into z inverse of z upon z minus 1. Now, as whatever the region of convergence is given to us, from that, for z upon z minus 2, we will consider mod z less than 2, and for z upon z minus 1, we will consider mod z strictly greater than 1, as this is the given region of convergence. Using the table of inverse Z transform, we will be getting inverse Z transform for Z upon Z minus 2, where the region of convergence is mod Z strictly less than 2 as minus 2 raised to n, and for Z upon Z minus 1 and region of convergence is mod Z strictly greater than 1, inverse Z transform is 1 raised to n. Hence, inverse Z transform of the given function is this 3 as it is, minus 2 raised to n, minus 2 as it is, 1 raised to n. For first term, it is n strictly less than 0, and for second one, it is n greater equal 0, and hence the inverse Z transform for the given sequence is minus 3 into 2 raised to n minus 2 for first term for n strictly less than 0, and second one for n greater equal 0. So this is partial fraction method. I hope you have understood this. In the next lecture, we are going to study third method, which is known as inversion integral method. Thanks for watching this video.